Hello, welcome to the third video for Edexcel IAL Physics, Unit 4, January 2019. Let's start. Question number 16. The structure of atom was investigated in the early 1900s by directing alpha particles at thin metal foil and measuring the angles through which the particles were deflected. Explain why these experiments were carried out in vacuum. It's just because of to avoid any collision between alpha particle with the air particle. It is possible that the alpha particles are absorbed between the air and it does not reach to the foil. It's just one reason you can write here to avoid the collision, and then it can stop alpha particle before the reaching the gold foil. So in one series of experiment, about 1 in 8,000 alpha particle directed at thin gold foils were deflected through angle greater than 90 degrees. Explain how this provides evidence for atoms having a concentration of charge in a central nucleus. So if you see that, if you can use your concept of mechanics, if some heavy particle is coming from somewhere and you need to bounce back this heavy particle in opposite direction, so you will have to apply a large amount of force in order to do that, because you are facing a heavy particle moving fast coming towards you. You need to bounce back, so you need to apply a large amount of force, and in this scenario this large amount of force is only possible if you have high concentration charge in a small region. Part C, the angle at which the greatest number of alpha particles was detected are gold. For gold was 2.1 degree. This is the greatest number of particles. Okay. The experiment was repeated for other metal foils. The results are shown in the table. Okay, gold, silver, copper, aluminum. Proton numbers, angles are here. Explain the pattern of results in the table. Clearly, if you see here what is happening, if you see the general trend, as metal is changed, the proton number is decreasing. So proton number is decreasing. That means amount of charge is decreasing. That means amount of repulsive force or magnitude of repulsive force is decreasing, and angle is also decreasing. So you have a less deflection. So you can say that basically the angle of deflection measures alternate measure of the deflecting force. So higher the deflection, more the force, that means higher the nuclear charge. So you can say that as proton number is decreasing or increasing, vice versa, whatever you say. So proton number is decreasing, so the amount of charge is decreased, so the deflecting force is decreasing, and the angle of deflection is also decreasing. These experiments provided evidence for a nuclear atom. Bohr suggested that electron can only orbit the nucleus at a specific distance from the nucleus. De Broglie developed this idea by stating that the lowest possible orbit is where the circumference of the orbit is equal to the de Broglie wavelength for the electrons. Show by considering the force keeping the electron in orbit around the hydrogen nucleus that this statement is true. So you need to show that the circumference of the orbit is equal to the de Broglie wavelength. So that means you need to find two things. First, you need to figure out how to find the de Broglie or de Broglie wavelength, and then you need to compare with the circumference of the orbit. The radius of orbit is given. So you know that de Broglie wavelength is lambda is equal to h by p, and where p is the momentum. That means you need to figure out somehow the momentum of the particle, and this is all about electron, because electron is orbiting. Yeah. Okay, so now let's see, because you know that in the nucleus of an atom, if you have atom here, this is the nucleus with the proton, this is electron with the negative charge. So between electron and the nucleus, it's all about hydrogen atom. So you have electrostatic force between the electron and one proton there. So the electrostatic force is behaving as a centripetal force. So the electrostatic force, call equation number 1. So electrostatic force between the proton and the electron in hydrogen atom is F is equal to K E square over R, because proton and electron both have the same charges. So Q1 Q2 means charge of electron, charge of proton, so Ke square over R square. And the same electrostatic force is behaving as a centripetal force, so M V square over R. And you can clearly rearrange this equation for V, and then if you rearrange for V, so V would be equal to K E squared by Rm. Now you have everything in your data sheet. You have a Coulomb's constant, you have electron charge, radius r is given, mass of electron is also given in your data sheet. So you substitute all the numbers here and you can figure out V here. So V you will find here is 2.2 into 10 to the power 6 meter second inverse. This is the velocity. And then if we have a velocity, now we can figure out the wavelength. So lambda is equal to h upon p as per equation number 1 here, and p is the momentum, so m into v. Now we have a v here, 2.2, we have mass in the data sheet. So you substitute the number, like h is Planck's constant, 6.63, 10 to the power minus 34. M is the mass of electron given in your data sheet, so 9.11, 10 to the power minus 31 times V we have found 2.2 into 10 to the power 6. Now we can figure out the wavelength. Lambda is equal to 3.3 into 10 to the power minus 10 meter. And the circumference C is 2 pi r. And if you solve this equation, so you have 3.32 into 10 to the power. So circumference you can figure out from this formula, so you can say that this is approximately same. Question number 17. The circuit shown is designed to test reaction time. Okay, this is the circuit. The following instruction will test the reaction time of a student. Hide switch S1 from the student move S1 to position 1 and wait until the voltmeter reads 6 volt. And then close with the close switch S2. At random time, move S1 to the position 2 so the buzzer sounds. As soon as the buzzer sounds, the student should open S2. Use the new voltmeter reading to calculate the student's reaction time. Explain how the circuit works to test reaction time. Clearly, if you see that if the switch is at S1 is at position 1, that means this is the charging position. So the capacitor is going to charge, fully charged, when the voltmeter reads 6 volt, as step number 2 says. And now what happened? You turn on the switch S2, that means you close the S2 and then move the S1 to the position 2. At that moment, the capacitor starts discharging through the buzzer and buzzer is sounding. So if the capacitor is discharging, the voltage around the capacitor is going to decrease from 6 to some value, and if the student is able to open the switch, then the capacitor is going to stop at some voltage. So you can use that new voltage read here, and then you can use the equation V is equal to V naught e to the power minus T by RC to figure out the time, because V is the voltage after time T and V naught is initial voltage. So you can use this equation to figure out T, and this T will give you the reaction time of the student. B. When the circuit is used with the particular student, the final voltmeter reading is 0.7 volt. Show that the student's reaction time is about 0.2 second. Capacitance of capacitor is 270 microfarad. Resistance of resistor is 332 ohm. Resistance of buzzer is 38. So we need to find or figure out the reaction time. We are going to use same equation. So V is equal to V naught e to the power minus T by RC. Now V is voltage after time T, which is 0.7, is equal to, this is initial voltage, which is 6 e to the power minus T we need to find, divided by RC. R is the total resistance, and total resistance is 332 plus 38, and it will give you 370 times it's ohm, yes, and then 270 microfarad, so 10 to the power minus 6. So you need to solve this exponential equation using your calculator. So you can do one. I'm just showing one more step. 6. So you can send 6 on the other side. So 0.7 divided by 6 is equal to e to the power minus T divided by, if you multiply these two numbers, it will give you 0.0999, and then you can use your calculator using ln or ln to remove this e. Once you remove this e, or you apply ln, calculate ln of 0.7 divided by 6, your answer will be minus 2.15 is equal to, this e is gone due to ln, and minus T by 0.0999. This minus is gone, and then T will be giving you 0.214 second. So it is approximately 0.2 second. Sketch the graph of potential difference across the capacitor against time when S1 is moved to position 2 and S2 is closed. So it is all about discharging curve, so you can use some initial voltage from here and then this is exponential discharging, so you can something like this with a smooth curve. Okay, that's how you can sketch this. This is V0, or you can say this is 6 volt if you wish. Explain how to make circuit more sensitive for a reaction time of 0.2 second. You should refer to the shape of your graph. Okay, for this type of circuit, if you talk about the sensitivity of a circuit, so sensitivity of that kind of circuit is how fast or slow the voltage is changing with respect to time. That means we need to see how to control delta V by delta T. This is the rate of change of voltage with respect to time, and delta V upon delta T is the gradient of this curve. So how fast the gradient is changing for that curve shows the sensitivity. So if you need to make your circuit more sensitive, so that means the gradient should be higher. If you increase your initial voltage, that means like if I show you, you don't need to mark here. If you increase your initial voltage, that means your gradient will be more higher than the initial value. So you can increase your initial voltage to make higher gradient, so rate of change of gradient will be more more sensitive, or you can say the large voltage change with the given interval of time. So it's all about how fast or how slow the gradient is changing. So for this gradient, you need to make your initial voltage higher or increase your initial voltage or charging voltage. The Moscow Meson's factory linear accelerator Linic is used in the production of particular isotopes for medical use. Strontium-82 is created by bombarding rubidium-85 with protons. Complete the nuclear equation to show this process. It is, of course, all the charge number on the left hand side of this arrow and the right hand side, and the mass number left and right should be same. So you know that this is proton, so it should be 1 and 1, and it is a strontium, it is neutron. So neutron charge number is 0, mass number is 1, and if you need to see that this 37 and 1, so it should be 38 here. And then if you balance the mass number, so you should use 4 here. The Moscow Meson factory accelerates proton up to energies of 160 million electron volt before colliding them into rubidium. The first 100 million electron volt is supplied using a Linic with drift tubes, as shown. Explain how the Linic accelerates the proton. It is a typical question about the Linic because you have drift tubes with increasing length, and this drift tube has increasing voltage or the opposite polarity in front of the source beam. So the source beam or the proton beam is attracted from the first cylinder, and the next one has higher voltage, so it can keep accelerating and accelerating. So you can say that the drift tube in front of the source has opposite voltage, and due to the voltage we have electric field in between the drift tube, and this electric field can cause a force on the beam that accelerates the proton. The diagram shows the path of a proton in the Linic, point A and point B. are at the center of two successive gaps between drift tubes. These are the 2 points in a single tube. The AC supply has a frequency of 198 million hertz or megahertz. The average kinetic energy of the proton as it moves from A to B is 2 million electron volt. Calculate the distance from A to B. You may assume that the proton speed is non-relativistic. Remember, it's all about moving of a particle in a tube. So between these 2 points, speed of the particle stays same. So speed does not change when moves in a single tube. That means you can use S is equal to Vt to figure out the distance between A and B. This S is the distance between A and B. So we need a velocity and we need a time. So for velocity, we can use the concept of kinetic energy, because the proton has energy, kinetic energy, 2 million electron volt. So we can use Ek, kinetic energy, and for time we can use T is equal to 1 upon F, because frequency is given. So first of all, we need to figure out V, and the V is equal to 2E divided by M. 2 and E is the kinetic energy, which is 2 million electron volt. Remember, this electron volt should be converted into joule once you figuring out the velocity. So you can convert this electron volt into joule, and then mass M is the mass of the proton given in your data sheet, 1.67 10 to the power minus 27. So 1.67 into 10 to the power minus 27 kg, and you can use these numbers here and you can figure out the V. So V would be equal to 1.96 into 10 to the power 7 meter second inverse. This is the speed between A and B. And then if you use T is equal to 1 upon F, that means this capital T will give you 5.1 into 10 to the power minus 9 second. As I told you that the speed stays same between A and B, that means during this A and B, another important point, just wait, because they are saying we have a AC supply. That means as the particle is traveling from A to B, the cycle is not changing, because AC supply has a 2 cycle. So this is the first cycle through which the proton is traveling from A to B. So the time that we found here is time for the whole cycle, and for A to B we need to use only time for half of the cycle. That means T would be equal to T by 2, because for the next half cycle the particle travels in the next tube and accelerate in the next tube. That's why we use T is equal to T by 2. Now we have a time, that means you can use 5.1 into 10 to the power minus 9 divided by 2. This is your time for only one tube, or between A and B. So you can use S is equal to Vt, and if you use that, you have a distance between the 2 points is 0.049, or you can say it is 4.9 centimeter. When the first Linic were made, the maximum frequency for AC supply was about 7 million hertz. Suggest why it is an advantage to use a much higher frequency than this. Clearly you can see that the time between in a tube T is equal to 1 upon F. So if frequency is higher, then time will be less. So less time, it will take less time to pass through the tube. That means it will be accelerating more and it will be gaining more speed. So higher the frequency, less time taken, so higher the speed reached by the particle. Thank you very much and have a nice time.